Hello guys. This is another model for vertical circular motion, a particle that moves in a vertical circular motion. It's a very important example, but we didn't see questions from these sort of models for the last couple of years, but they came up before 2010, especially 2005 A-level question. Please go through that and see. And it's about a particle suspended by an inextensible string, and the particle moves in a circular path, right? What is so special about this problem is that about this model is that the particle is suspended by a string. Now you know that string is good under tension, but it is not good under trust, right? Uh, so I couldn't find a string. Imagine this wire to be a string, right? So under tension it's good, but so it can't hold any trusses, right? So that is that is a problem with this circular motion, because if this is a rod like this, if the particle is attached to the rod, right? So even if it doesn't move completely, it will come back in the circular motion. It will stay on the circular motion, right? Because the particle is fixed to the circular motion, like we saw in the examples, right? Maybe particle in a thin tube or a ring on a hoop, so those are fixed to the circular path. Now since a particle is suspended on this string, what happens is that it can be partly on partly circular motion, which means when it goes up, in some cases the string can't hold it. String can't give tension. The tension becomes zero. If tension becomes zero, what happens is that there is no forces acting towards the center of the circular motion, which means the particle must leave the circular path, right? So after that, particle will take on a different path. For example, it will move under gravity. So in that case, the particle will have two types of motion. Initially the vertical circular motion, partly vertical circular motion, then projectile motion. So this is very important. Now because we have to look for the tension, where the tension becomes zero and all, and maybe you get questions like this, then what happens after the particle takes on the projectile motion, where it will land, those things can be asked. But nowadays, since circular motion is just a part of a question, you don't really have to expect these types of questions, right? So in partly circular motion, this is why we studied partly circular motion. This means it moves in a circular motion partly, right? It has a circular motion partly, then it takes on a different path. So in some cases, a particle will move in a circular path partly and then takes on a different path. For example, projectile motion, right? So I have listed out three scenarios here. Now you can see that this is a particle suspended on a string, and suppose you give a velocity, right? Give a velocity u here. Now if it has enough juice mean enough kinetic energy, right? If it has enough kinetic energy, it will start move in this circular path, right? So when it is moving in a circular path, you know that the level vertically it raises, it is raised vertically, which means the potential energy changes. So to accommodate the potential energy change, you need to have certain kinetic energy. Now suppose it doesn't have kinetic energy to rise up to this point, right? So this is the complete circular path. If it doesn't have enough kinetic energy, what does that mean? It doesn't have enough kinetic energy to move up to this point, right? To give this potential energy. Not enough means this inequality. So we will prove this. Definitely we will prove this in the next part. U squared is 2gl less than 2gl. If this is the case, particle will move up to a certain extent, but it will stay below this level up to a certain extent, right? Then it will come back, right? So, and will stick to the circular path, what it will happen is it will oscillate, right? So you can see it will rise up to this point and loses its kinetic energy, then it moves back in the circular path. Now, in this case, even though it looks like it doesn't take on the whole path, still in a circular path. So this is full circular path, right? The path is circular, that's why. And what happens is that the particle starts oscillating. So this is the model of oscillation. Next, partly circular motion, what will happen is that if the particle has enough energy to surpass this level, right? Surpass this level, it will go up. It will go up. And sometimes, right? So I will tell you at what times the tension will become zero. So now two things can happen. Maybe since it does not have enough juice, right, to go on the full circular path, it might loses its kinetic energy. That means velocity will be zero. In that case, the particle will drop, right? Or tension will become zero. Tension will become zero. So if tension becomes zero, which means no forces towards the center. No forces towards the center, right? So there will be a component of gravity, but you know that that is not always directed towards the center. So gravity will always directed towards the earth. So what happens is that when it loses the tension energy, when tension is zero, the particle will takes on a projectile motion, right? මේ වගේ වෙනවා මෙතනින් ගියවහම මොන particle එක එනවා. So you can see that from here to here it will take on a circular path, right? From after here what happens? It takes on a projectile motion, right? So once it comes down to this position, the string will be tied again. It's like this. String will become tied again and it will move in a circular path. So this is a different path. You can see from here to here circular, then projectile, then again circular, projectile, circular, projectile. Okay, good. So when will that happen? That is when u squared, the initial velocity u squared, is less than 5gl or greater than 2gl. If it is greater than 2gl, it will move above this level, but what happens is that it will take on a different path, right? So this is an example of a partly circular motion. Now the other thing that can happen is that it will move in a full circle, and throughout, when it is moving in a full circle, which means the tension will always be there. Tension will always be there. It will be present here, and also it will have some speed, right? That's why it can move. If it doesn't have speed, it can't move. By speed, I mean the kinetic energy, right? So in this case, the particle will take on a full circle, and that is when u squared is either equal to 5gl or greater than 5gl. If this is the case, the tension will always be there, present, or we can say tension is always positive, and also the velocity will always be positive. Right. So these are the three cases that we're going to study, and now we're going to look into the model. Right. So we're going to start with the basic example. A particle hangs. Particle is suspended by a string, right, and it is fixed to a point O. Okay. So the length of the string is L. Right. Now when it's at this position, I'm going to give it a velocity u. So what will happen is that it will acquire a kinetic energy, and that kinetic energy can accommodate a potential energy change, right? So potential energy change means the particle will elevate. So how does it elevate? It will move in a circular path. Why? So when you are given a velocity in this direction, particle tends to move in this direction linearly. So what happens is that since this is inextensible, it can't move in this way because the string gets tight and the string wants to move in a circular path. For example, you can see, right? So if I try to move in this direction linearly, you can say the string takes me on a circular path, right? Because string is inextensible. Make extend when with the මෙයාට ෆික්ස් වෙලා තියෙන හින්දා මෙයාට කෙලින් යන්න බෑ. මෙයා අදිනවා. ස්ට්‍රින්ග් අදිනවා නෑ නෑ යන්න එපා. ඔයා මාත් එක්කම ඉන්න ඕනේ මෙච්චර එල් දුරකින් කියලා. ඔන්න ඔක තමයි වෙන්නේ. Right. Okay. So suppose it makes an angle theta with the downward vertical. So this is a general location, and I mark all the forces mg that is directed towards the earth, and the tension, definitely mark the tension on the string, and it will have a certain velocity v, right? So the centripetal acceleration is v squared over L, tangential acceleration is dv by dt. So we have two acceleration types when it comes to vertical circular motion. If it is horizontal circular motion, you know that the velocity will not change, right? Velocity will not change means dv by dt. dv by dt in simple terms means rate of change of velocity. This is a derivative. Derivative gives you the rate of change. Okay, so velocity does not change means rate of change will not occur, which means this part will be 0 in that case. But since we are looking at vertical circular motion, this part will also be there. But most of the time we are going to use v squared over L, centripetal acceleration. Okay, so let's derive equations for this. First of all, we need to know what our velocity would be at this position, because you know that when you want to use F equals ma towards O for the centripetal force, you need to know what the velocity at this point is, because the acceleration v squared over L, right? So you need to know v first. To find v first, we should use energy conservation laws, and right, so let's take this to be our PE0 level, or you can take this to be your PE0 level. That's totally up to you. So I'm changing this in every example so that you get used to anything, right? So initially and finally. So what happens is that let's take finally at this level. Okay. So our kinetic energy at this position would be half mv squared. That is our kinetic energy. Let's write it all the way here. Okay, so half mv squared at this level, plus what is the potential energy? Now it is below this level, so it should be negative mg plus mg negative, so L cos theta, negative L cos theta. That is equal to, initially what it was, the kinetic energy half mu squared, and the potential energy is plus mg minus L. So it's okay if you put minus mgl straight, or minus mgl cos theta. That's totally up to you. So you can see that m goes off, cancel out, and I can multiply this whole thing by 2. So v squared, I want to find what v squared is. Now v squared equal, u squared is also there, right? 2 goes off because I'm multiplying this whole thing by 2. If I take this out, onto this side, I get plus 2gl cos theta minus 2gl, right? So to make stuff simpler, let me take negative sign, negative 2gl, then 1 minus cos theta equal v square, right? So this is equation 1. Okay, now we found what our velocity is. Now you can see that u squared, this is a negative term, which means this can be 0, v can be 0. So if we don't have enough energy, enough kinetic energy, the v will be 0, right? Right, so because this depends on theta, so it's totally up to you. Okay, so we'll derive these. Right, next we have to find the tension, because as I mentioned earlier, tension can be 0 as well. So tension has to be positive for the particle to move in a circular path. So we need to find the tension as well. So let's write F equal ma in this direction, right? So what do we have? We have T in this direction and mg is downward, so the component is mg cos theta minus mg cos theta is equal to m. What is the centripetal acceleration? F squared v squared over L. So the tension is now mg cos theta plus m v squared over L. So let's take m out, then g cos theta plus v squared over L means u squared minus 2gl 1 minus cos theta divided by L. Right. So m, this would be u squared over L. Now see what happens. If I divide this thing, L cancels out, then I get minus 2g, then plus 2g cos theta. We have g cos theta, that means 3g cos theta minus 2g. Right, minus 2g. So let me rewrite this, v squared over u squared over L, right? Then plus, let me take mg outside, then 3 cos theta minus 2. So this is tension. This is tension, right? So this is equation 2. Okay. Now we need to analyze these motions. So I'm gonna only write these two equations on the board, and we'll see what to do next. Now, as I mentioned earlier, particle will not complete a circle, right, if V becomes 0 or tension becomes 0. So what happens if V becomes 0? V0 means no kinetic energy, so it can't move after that point. So it might come back, right? T becomes 0 means no force directed towards the center. So you have to have a centripetal force, right, directed towards the center for the particle to move in a circular path. So that force actually takes a particle on a circular path, right? So if either of these two happens, the particle will not complete a full circle, or sometimes it will take on another path like projectile motion, right? So if this happens, what happens? You can have two things: either it will oscillate, right, or it will move and takes on a projectile motion. These two things will happen. So let's find it out. And to analyze this motion, let us make V equals 0 and find where will it happens and at what conditions. And let's make T equals 0 and let's see where the tension will become 0 and what conditions that will happen. Right. Okay. So V equals 0. Let's say V becomes 0 at a certain angle at theta equal alpha. Right? When theta becomes alpha, now this is theta is in general, theta is a function, right? So theta වලට මොන හරි values දාන්න පුළුවන්. මොකක් හරි angle එකකදී V 0 වෙනවයි කියලා ගන්න. එතකොට මොකද වෙන්නේ? At this point, what will happen is that 0 becomes u squared minus 2gl 1 minus cos alpha. So let's take a value for cos alpha from this. So u squared equal 2gl minus 2gl cos alpha. Then cos alpha would be 2gl minus u squared over 2gl. This is third equation. This is third equation. Now, why did I find cos alpha? Alpha gives you a sense of where you are, right? So angle tells you where you are. If angle is angle is 0, that means you are at the same initial position. If angle is 90 degrees, you are here. If angle is pi, then you are on the top, right? 3 pi by 2, like this, right? It moves, okay? Oh, this thing could also happen. Let's say t equals 0 at theta equals beta at some value, right? So these two may not be 0 at the same time. They may not be at 0 at the same time. Let's see. Okay, tension becomes 0 means mu squared over L plus this equals 0. So let me take it to the other side, minus mg 3 cos theta plus 2 mg, that is the answer. So this is at beta. So let's subject beta and see what happens. M cancels out, and 3g cos beta would be equal to 3gl. Why 3gl? I'm gonna multiply this whole thing by L as well. So u squared minus 2gl minus u squared. So cos beta would be 2gl minus u squared over 3gl. This is our fourth equation. Now look what happened, right? So this gives you a sense of what it is. Now alpha, let's take cos inverse of this value. Beta 2g cos inverse 2gl minus u squared over 3gl. Now you can see that these two are different. What is the difference? Here in the denominator you have 2gl, here in the denominator you have 3gl. So these angles are not the same. Not the same except for when this is 0. This part is 0. Suppose u squared is equal to 2gl. Then what happens? U squared equal to 2gl means this part will be 0. This part 0 means alpha is pi by 2. Alpha is pi by 2. So it's somewhere here. Moves like this and pi by 2. At this point, that means when u squared is equal to gl, this is where it's at. And same thing happens to tension. Tension will also become 0. U squared equal to gl, right? This part will be 0. Beta becomes pi by 2, which means at pi by 2 tension will also be 0. Now, so which means these two are equal at only one point, that is when the particle, so it starts moving from here, and when it is at here, at this position, both will be 0. So that is the only point. I mean, other than that point, T and V will not be the same, right? I mean, beta and alpha will not be the same for any other position, right? They are always different. Okay. Now let's write these two equations down as well, so that we can analyze them. Right. So now what happens? Let's start. U squared, this is case 1. When u squared is less than 2gl. If u squared is less than 2gl, so let's see what happens. Where will our particle be? Right. So let's look at cos alpha. U squared is less than 2gl means this part, the numerator, will be positive. Here again also positive. But 2gl, 3gl. So which means now cos alpha, in this case, cos beta is less than cos alpha, right? Here we have 3gl. Then මෙයා 3න් බෙදනවනේ. Right? It is divided by 3. This is divided by 2. तर වැඩියෙන්ම divide වෙන්නේ මෙයා in the cos beta. මේ පාත් cos beta and cos beta less than cos alpha. But they are both, they are all positive. Always positive. So when is cos alpha positive? Cos theta positive, cos theta is positive in the first quadrant and fourth quadrant. So we don't really worry about fourth quadrant now. We can say, right, fourth quadrant or first quadrant, right? So with respect to the circular motion, theta, right? So we measure from here. This is the first quadrant, second quadrant, third quadrant, fourth quadrant, which means our cos alpha and cos beta, let's take theta, is in these two regions. That means below this level. Below the level of O. Now cos theta is strange, which cos theta starts from 1 and goes to 0. බින්දුව ඉඳන් එකේ ඉඳන් බින්දුව වෙනකන් යනවා. That means cos function decreases on. තේරෙනවනේ? Right? cos එකේ function එක මේවා. Right? So when angle increases, cos of that angle decreases. So in this case, when cosine value are like this for two different angles, this implies alpha is less than beta. අනිත් පැත්ත ගන්න. Alpha is less than beta. Alpha is less than beta means alpha is related to this cos alpha, right? Alpha is related to this. That is when V becomes 0, right? Beta is related to tension. ඒ කියන්නේ මෙන්න මේ වගේ අවස්ථාවක්. මෙයා alpha නම් beta වැඩි වෙන්න එපා. This is beta, right? So the velocity of the particle becomes 0 at this position, right? Tension would become 0 at this position. So what does this mean? Velocity becomes 0 before the tension becomes 0, right? If velocity becomes 0 before tension becomes 0, the particle will definitely stop there and start oscillation, right? So මේ කියන්නේ මෙයා beta නම් particle එක 0 වුණොත් velocity එක 0 වුණොත් එතනින් එහාට යා move වෙන්නේ නැහැ. එතනින් ඊට පස්සේ oscillate වෙනවා. So this implies මේකේ මම දාන්න implication එක. This implies velocity becomes 0 before tension does. Right? Velocity becomes 0 before tension does. ඒ කියන්නේ මෙයා particle will oscillate. Right? Particle will oscillate. तर මේ වෙලාවේදී මෙයා 0 වෙන වෙලාවේදී tension එකක් තියෙනවා. ඒ වෙලාවේදී tension එකක් තියෙනවා. particle එක oscillate වෙනවා. तर මෙන්න මේ වගේ idea එකක් තමයි මෙතන තියෙන්නේ. එතන O තියෙනවා නම් මුලින්ම alpha වෙනකන් විතරයි යන්නේ. particle එක V becomes 0, but there will be a tension associated with it. Then it moves back like this until this point. This is also alpha. මේ alpha එක එන්නේ මේ fourth quadrant එක. circular motion එකට අදාළ fourth quadrant තමයි මේ. එතන මෙයා ඔයම oscillate වෙනවා. දැන් මේ V0 වෙද්දි tension එකක් අනිවාර්යයෙන්ම තියෙනවා. එතකොට මේ region එකේ මේකට වැඩි අඩුවෙන්, right? Below this level there will always be a tension, right? And even though the velocity of the particle becomes 0. මේ තමයි first case, right? Second case is when u squared equal 2gl. U squared 2gl means cos alpha will be 0 and also cos beta will be 0. These two are equal, they are both equal to 0. So when does that happen? When alpha equals beta equal pi by 2, right? Then nama 0 වෙනවා. ඒ වෙලාවේදී mg විතරයි තියෙන්නේ. ඒතර මෙයා O නම් මෙන්න මෙතන තමයි particle එක තියෙන්නේ. right? ඊට පස්සේ I circular motion එකේව particle එක යනවා. මෙතෙන්ටම trace වෙනවා. I යනවා. හරි. This is now alpha equals beta equals pi by 2. Right? So may I rise up to this position and moves back in the circular path. So මෙතනදි circular path එකේම තමයි particle එක තියෙන්නේ. ඊළඟ බලමු case. Right. So case 3, when u squared is greater than 2gl, that means this will move above, and less than 5gl. Where did this 5gl come from? So now you know that cos alpha, cos beta, whatever that is, cos theta, this angle must be less than or equal to 1 and greater than or equal to -1. Now this is a must. Cos theta වලට එකට වැඩිව තියෙන්නත් බෑ, negative 1 වලට වැඩිය අඩුවෙව තියෙන්නත් බෑ. දැන් මෙතන බලමු 5gl. දැන් මෙතන values දෙකක් තියෙනවා. මෙයා satisfy වෙන. මෙයාට ගන්න පුළුවන් minimum value එක ගන්න නම් we have to put u squared equal 5gl. මෙතන 5gl දැම්මොත් 2gl minus 5gl, that is 3gl. 3gl divided by 3gl, that is minus 1. तर මෙයා satisfied. ඒක ප්‍රශ්නයක් නෑ. මෙතන මොකද වෙන්නේ? මෙතන 5gl දැම්මම උඩ minus 3gl එනවා. Minus 3gl divided by 2gl, that is more than 1. So that is minus 1.5. මෙතනට minus 1.5 වෙනවා. මෙයා ඉන්න හින්දා තමයි අපි 5gl ම දැම්මේ. මොකද තව ටිකක් මෙයාට ඉස්සරහට යන්න පුළුවන් හින්දා. මෙයාට වැඩි මෙයාට ඉස්සරහට ටිකක් යන්න පුළුවන් හින්දා අපි දැම්මේ. So හොඳට මතක ගන්න මේ ටෙන්ෂන් එක. right. So 5gl අවස්ථාවේදී at that condition, cos alpha will definitely not exist. cos alpha exist වෙන්නේ නැහැ කියලා කියන්නේ velocity එක 0 වෙන්න විදියක් නැහැ කියන එක. හරි. cos alpha අපි ගත්තේ velocity එක 0 කරලානේ. ඒතර cos alpha exist වෙන්නේ නැත්නම් ඒ කියන්නේ ඒ වගේ angle එකක් නැහැ. alpha කියලා angle එකක් නැහැ කියන්නේ velocity එක 0 වෙන්න බෑ කියන එක. ඒතර velocity එක 0 වෙන්න angle එකක් නැහැ කියලා. velocity එක 0 වෙන angle එකක් නැහැ කියලා කියන්නේ velocity එක 0 වෙන්න බෑ. හරිද? ඒ හින්දා ඒක ප්‍රශ්නයක් නෑ. velocity 0 වෙන්නේ නැති කියන්නේ particle එකට move වෙන්න පුළුවන්. හැබැයි අපිට මෙතන මෙයත් එක තමයි ඊට පස්සේ deal එක තියෙන්නේ. හරි. So that's why we get 5gl here. ඒතර ඒ part එක ලියා ගන්න ඕනේ නෑ. ගානකදී මේ වගේ දෙන්න පුළුවන්. So what will happen here is that when this is the value, now u squared is greater than 2gl means this part will be negative. This part will also be negative, right? So these two would be negative, both of them. Cos alpha or cos beta would be less than 0. But they have to be greater than minus 1. අනිවාර්යෙන් දෙන්නම greater than minus 1 වෙන්න ඕනේ. දැන් මම මේ ක්‍රම එකක් දාලා තිබ්බ දෙන්නම මෙහෙම වෙනවා. දැන් මේ තියෙන්නේ cos alpha cos beta negative පැත්තේ. तर cos alpha cos beta negative ගත්තාම මෙයාගේ negativity එක මෙයාගේ negativity එකට වැඩිද අඩුයිද? මොකද ඉතින්? මෙයා divide වෙන්නේ 2gl මෙයා divide වෙන්නේ 3gl. හරිද? तर මම මේ උඩ එක අපි නිකමට ගමු example එකක්. For example u squared equal 4gl. දැම්මොත් මොකද වෙන්නේ? cos alpha කියන්නේ this would be minus 1, right? මෙතන දැම්මොත් minus 1 එනවා. cos beta කියන්නේ කීයද? එතන 4g 2gl minus 2 over 3 වෙනවා. minus 2 over 3 කියන්නේ this is minus 0.66 something. හරි. 66 something. දැන් බලන්න මෙතන මොකද වෙන්නේ? cos beta must be greater than cos alpha. ඇයි මෙහෙම ලියුවේ? Why did I write it like this? Because cos alpha is minus 1, cos beta is minus 0.66. तर minus end එකේදී මෙයාට වැඩි. හරි? මෙයාට වැඩි නම් beta must be less than alpha. Beta less than alpha වෙනවා. Beta corresponds to tension becoming 0. That means tension becomes 0 before velocity becomes 0. ඒක තමයි අපේ argument එක. මම මෙතන example එකක් දුන්නා. तर අපි in general for any u squared value between these two values, we can say that cos beta is greater than cos alpha, which implies beta is less than alpha. Beta is less than alpha. Right? Beta is less than alpha, and also since they are negative, මේක අනිවාර්යෙන් pi වලට වැඩි අඩු වෙන්න ඕනේ. මේ දෙන්නම pi by 2 වලට වැඩි වෙන්න ඕනේ. Right? They both has to be greater than pi by 2, because in the second quadrant this will happen in the second and third quadrant. So let's focus on the second quadrant first. Second quadrant කියලා කියන්නේ මෙන්න මේ වගේ මෙතන දැම්මහම මෙයා උඩට ගිහලා මෙතෙන්ට pi by 2 මෙතෙන්ට pi වෙනවා. So this is a moment like this. මෙන්න මේ වගේ value එකක් තියෙනවා. හරි? මේ වගේ value එක නෙමෙයි මේ වගේ position එකක්. Right? So what happens is that this is now beta must be less than alpha. This is beta Suppose there's another location that is alpha. I'm not going to mark it out. The reason is that tension becomes zero at this position. Tension becomes zero first. Now the particle still has a velocity which is greater than zero. If it still has a velocity greater than zero, which means it has a kinetic energy. Kinetic energy එකක් තියෙනවනේ මෙයාට move වෙන්න පුළුවන්. එතනින් එහාට මොකද වෙන්නේ? කෙලිම particle එක projectile motion එකේ යනවා. මෙතනදී කියන්නේ T becomes zero, in other words slack, before V become zero. T becomes zero before V become zero, right? So which implies particle will take on a projectile path. It will take on a projectile path, right? So මේ තමයි case 3. ඊළඟට බලමු case 4. Right, case 4 is when u squared equal 5gl. U squared 5gl means this becomes minus 1. දාලා බලන්න. Cos beta minus 1 කියන්නේ beta equals pi. That means tension becomes 0 when the angle is pi. මෙතනින් දැන් උඩටම ආව topmost position එක. Cos alpha, what happens to cos alpha? Cos alpha becomes minus 1.5, which means cos alpha does not exist. ඒක වෙන්න බැරි වැඩ. Does not exist mean velocity එක 0 වෙන්නේ නැහැ. 0 වෙන angle එකක් හොයාගන්න බෑ, which means velocity will not be 0. Which means there will be a velocity when the particle is at its topmost position. දැන් මේ වෙලාවේදී tension එක 0 වෙනවා. ඒතර එක්කෙනෙක්ට හිතන්න පුළුවන් tension එක 0 වෙනවා නම් එහෙනම් directed කිසිම force එකක් නැහැ towards the center. But think about this. At this position මෙයාගේ mg හරියටම towards O තියෙනවා. ඒතර මෙයාට support එකක් තියෙනවා circular path එකක යන. body support එක V වල. අනිත් එක තමයි මෙයා V තියෙන හින්දා මෙයා ඉස්සරහට යනවා. කෙලින් යන්න බලනවා. කෙලින් යන්න බෑ. කෙලින් ගන්න ගිය ගමන් මෙයා මේ tension වෙන්න ගන්නවා. string becomes tension, right? string එක tension වෙන්න ගන්න. මේක හරියට මේ උඩ තියන්නේ. උඩ තියලා මෙතනදී tension එක මෙහෙම loose වෙනවා. slack වෙනවා. Then it starts to move with the string එක tension වෙනවා. මොකද හරියට මෙතනදී horizontally තියෙනවා. So top position but still has V, so moves in a circular path. So it takes on a full circular path. Let's look at the final case now. Right, so the final one is when u squared is greater than 5gl. If greater than 5gl, for example 6gl. 6gl දාපු ගමන් මෙතන minus 4gl divided by 3gl එනවා. Greater than less than minus 1 එනවා. මෙතන definitely less than minus 1. Make this becomes minus 2. Right? Which means neither cos alpha nor cos beta exists. So cos alpha or cos beta do not exist. එදෙනේ කිසිම දෙයක් exist වෙන්නේ නැහැ. exist වෙන්නේ නැහැ කියලා කියන්නේ කිසිම angle එකක් නැහැ. V and T දෙන්නම 0 වෙනවා. And always there will be velocity and always there will be tension. Always tension means will definitely move in a circle. Always V means definitely has kinetic energy. So no such angle where either V or T becomes 0. That implies move in a complete circle. So මේක තමයි අපේ model එක. හරි. તો මොනවාරි ප්‍රශ්න තියෙනවා නම් ඔයාලට මගෙන් අහන්න පුළුවන්. Now we can go through the past paper question 2005 and 2018. So 2018 is very easy question. Go through it and see whether you can try it. Thank you for listening.